right? The table name is sales by country wise, correct? So you can see select the star from sales by country wise, right? So if you want to see the partitions, you can write show partitions sales by country wise. Right, so we have the four partitions, two partitions on India and one partition is US and another one is AU. Okay, so if you write select star from sales by country wise, right, where what we have, let me check, is sales by, right, now we write select star from sales by country wise, where country like, so from US, right, where country like you can see, right. Now what it searched only the US partition and it retrieved the records. See how much time it took? Only 0.2 seconds. In the previous run, to list all from the sales by country wise, it took 0.614 seconds. Okay, now what it did, it checks only the data, only the information on that specific partition where the partition column is US. So instead of searching the entire table, it will search on the specific column or specific partition which is specified in the partition name, which is country here. Okay, now I have some data is available in the table sales by country wise. Now from this table, I want to take the data to another table, right, and I want to execute, I want to see the some sample execution, right, some specific users to see their information. Then what we'll do now, whatever the table we are going to create, so we'll divide into the some set of buckets. Right now the data will be distributed into the number of buckets. Now whenever you are going to run the data query, now you can able to run this query on specific data, right, specific bucket. Suppose you have created the four buckets, that is we have a bucket 1, bucket 2, bucket 3, bucket 4. Now if you want to see some test execution on bucket 3, right, we can able to do that, right. So the buckets are used to perform the some execution, some sample execution on the random data, right. So this is we use buckets. See here, suppose we use table, same thing, right, create table, some new table. So I'm writing some bucket data, new bucket data. My table name is create table new bucket data. Now from this new bucket data table, I want to take the data, right, from the previous table, that is the sales by country wise. Okay, so now I'm going to create a table. The table name is new bucket data, right. Now so I want to take some fields, right, that is a prod id, we have name, country, right. So I'm writing create table, the table name is new bucket data. So in this table I want to take so these three fields, right. After that I'm writing into four buckets, Right now this table is created and this table contains four buckets. Now the data which you are going to load in this table will be converted as a four buckets. So I'll write something like insert overwrite, the table name is new bucket data, right? So I'll write, so I just want to insert the data and I want to overwrite if any data is there in the new bucket data. So I wrote insert overwrite table new bucketed data, right? So what I want to display in this table, I want to display select prod id comma name comma country from the table name sales by country wise. Okay, now what happens, from this table sales by country wise, I'm taking the product id name country and I'm inserting into the table a new bucket data, and the data which are inserting into the table will be converted into the four buckets, right? That is bucket 1 will have some records, bucket 2 will have some records, bucket 3 will have some records, right? See here, right? Can write, right? So create table, so give the table name. I'm going to create table new bucket data. So in this one I want to take the three fields what we have, right? So one is a product id, product name, and other one is country, right? So write prod id is an integer, prod name is a string, country is a string, right? Now so I want to create at the table, right? The new table, right, which will have three fields, and how many buckets I want to create, four buckets. Then write into four buckets, right? So when you're creating the buckets, you take what is the column here, specify one column, one field as a id, so that it's easy for us to create the buckets, right? So I'm writing create table, but some table new table name which will contains the buckets, right? Write the fields. Now here I'm writing some, right, clustered by id into how many buckets you want to create, bracket names into four buckets, right? So we have created a new table, right? What is the new table name? You can see DESE new bucket data, right? Now we have the three fields. One is a product ID, and other one is a product name, and other one is a country, right? Now what I want to do is I want to insert some data, right, from the table name sales by country wise. So right, insert into, right, which table I want to insert, write the table name. So the table name is new bucket data, right? I want to insert select prod id comma prod name comma country, right, from the table name sales by country wise. Okay, now what it will do, it will insert the data into the new bucket data from the table sales by country wise. Before that one, right, just write enable the bucketing by writing set hive dot enforce dot bucketing equal to true. So when you write set hive dot enforce dot bucketing dot equal to true means now you are enabling the buckets for this table. So right, set hive dot enforce dot bucketing equal to true. Now next insert the data. Now it will insert the data as buckets. Right, right, just write insert overwrite the table name. The table name is new bucket data. Right, from this table I want to insert the data. Right, so write this query. Now recognize input here, new bucket data. Right, you have to write insert override the table. You have to specify here. Now it will load the data into 4 buckets. Right, so number of reduced tasks determined 8, the radius is 4. Okay, now 4 buckets are in, data is loaded into as 4 buckets. See, right, so new bucketed data will have 4 buckets. Right, buckets 1, bucket 1, bucket 2, bucket 3, bucket 4, and we'll have specific records in bucket 1, specific records in bucket 2, specific records in bucket 3, specific records in bucket 4. Like the total data which you are going to load into the table will be distributed as 4 buckets. Right, suppose if you want to
How
see the data, you can write here select star from the table name new bucket data. Right, so now which one data you want to display, some table sample. Right, table sample. Now which one you want, bucket 1. Right, so then when bucket 1 out of 4 on prod id, you have to write this. Right, select a star from the table name. The table name is new bucket data, so take some, right, Disable data, right? Table sample bucket 1 of 4.
Data spelling is wrong. New bucket data.
Yes. Now it will display the data from the bucket 1.
Ajay, why did we, what is that for clustered for? While creating a bucket, we use a clustered word, right?
Yes, because all the see generally we have two things. One is a clustered by, and other one is ordered by. Right now, when I want to specify the data, so I will take the cluster. This cluster have clustered data by the clustered ID. Okay,
I mean, I didn't get that. What is? Can you just say it again?
right. See, we have clustered and non-clustered indexes, right? So this clustered by. So what it will do? It distributes data right here in Hive reducers, right? It's by the key hash. So what you have specified, right? With that key, it will distribute the data, right? So now what I did, so when you are loading the data, now what is the I have specified here. I have specified into 4 buckets. Then I wrote clustered by, correct? So now here the particular column I am taking hash key as a product ID. Based on that one, I'm distributing the data into the 4 buckets. So I wrote clustered by.
Okay.
Okay, so if you write ordered by, right? So what
So we can write anything, right? I mean, the clustered by any column rather than
you see,
priority.
you can use order by, you can use cluster by, and you can use distribute by. So
So it's like an index or what?
yes, right. So as of now, these are available, right? You can use order by and sort by and clustered
What
by.
is the use of that?
Which one?
I mean, clustered by. If you use a clustered by, retrieving will be fast or anything. What?
Yes, it will be fast, right? Because
Okay.
see, the it is using some hashing, right? So based the hash column, you will be at the product ID. So based upon the hash column, the data is distributed into the 4 buckets.
Okay.
Insert override new bucket data, right? Now what I want to take, I want to take select star from select prod id comma prod name comma country from sales by country. Here right, new table name here right. right? So number of reduced tasks determined at the compile time is 5, right? So number of mappers is 1 and number of reducers are 5. Now 5 reducers will equally distribute the data by taking prad id as a hash key, and it will distribute the data into 5 buckets. Right, so table is a new bucket data, so number of files are created is 5, right? So there are total 13 rows loaded into new bucket data, right? So there is a one map with the 5 reducers, right? Now you can see Hadoop space fs hyphen ls user hive warehouse and new bucket data, right? Now it created the 4 partitions. You can see Hadoop fs hyphen cat new bucket data, and the part file is 000000 underscore 0 is the first bucket. Okay, now you can see the second bucket 1 underscore 0. So this is we have in second bucket. So third bucket, so fourth one.
So third is blank. We don't have.
Yes, third is empty. Right, you can see like this. Select start from bucket, select start from new bucket data, then write table sample, then bucket 3 out of 4 on
5.
out of on prod id, right? So we have this one in the bucket 3, right? We have one record in bucket 3, that you can see the same output here, bucket 0 right? So this is what we have in bucket 0.
Ajay,
Yes.
don't we have the delimiters while loading data in buckets?
No, I have not specified the delimiters, right? It uses the default delimiter. That's what we got the symbol blank space. Okay. So the
I
default,
don't see any space.
you can see the delimiter here.
No, is there a space between the two fields? Because it
It's a
looks like.
default. It's a default delimiter. So the Hive created by every table in Hive will follows the default delimiter if user not specify that. Right here, it took the default delimiter as a blank
Okay.
space, which comes with Control A. Right, which we cannot. It's not the space from the space bar. It is the space taken from the Control A. Okay, so that is the
Okay.
default delimiter. Right,
Okay. In
that's
case
what.
if we want to
Yeah,
define
that
the
so this.
delimiter,
Then you have to write the delimiters, right? But most of the times we use the default delimiter because we are getting the data from other table where you have specific data with the delimiters. If you want to write your any job, any program, you write on your regular table. So this is only the bucket table, just for only the sampling we are checking this one, right?
okay, but won't it take the delimiter from the table which it's taking the data?
No, because we specified in the query to insert the data from this table, right? I have created table this into 5 buckets, that's it. And I have not specified any row format, anything, right? So what it did, it took the default delimiters, right, and it created the table. Okay,
Okay, Ajay, fine.
right, if you're not specified any delimiters, it will take the default delimiters. Right, we'll see. Hive giants. So I'll create some data, right? So I'm writing some product ID and the product name. To iPhone 3, right? So I took, so it's a product ID and the product name, right? I'm saving this. I'm creating a folder in documents. The folder name is Hive Giants. Create a folder. folder name is Hive Giants, right? I'm saving, it's a prod info, right? So where we have product ID and product name, right? I'm taking other one, that's user info, right? So username and the product name. So then write Shiva is having the product one, right? So when we are writing the giants, we must have a common column in both the tables. Three, 7, right? I'm saving this as user info. Okay, so one table is a prod info and other table is a user info. Then I'll create a table like this, create table. The table name is user info. Okay, so where we have the first is username is a string, prod id is an integer, correct? Then row format delimited, fields terminated by /t, right? I'll create other table. So prod info, right? So what we have, prod id, prod name, right? So we have to load the data. So I'm writing load data local in path, have the data in, right? cd documents, right? pwd, right? So this is the location where I'm having input data less, right? So first we load from the prod info into table prod info, right? So first we'll create these tables. Yes, right? Drop table if exists. What is the table name? User info, right? Drop table if exists prod info, right? So we have created a table user info, then we'll create a table prod info, right? So create a table of, right? So we have created the two table, that is DAC user info, DAC, prod info. Correct? Now we have to load the data. Right, from the prod info, user info, user info. Right, copy. So we would load here, we have right here. Right, so we have loaded the data into the two tables. One is user info, another one is prod info. Now you can see, select start from user info, right? Then select start from prod info. Okay. Now,
you got a text from VM Amazon. Read it or ignore it.
okay, so now we have to write the giants. Now when we are writing the giants, so we have to identify, so what is the common column in the two tables, right? So without knowing the common column in the two tables, it's never possible to write the giants, correct? So now, so what is the
Did you
common
want to read
column
it
here?
or ignore
We have
it?
the common column, that is a product ID,
Sorry. Read it or ignore it.
right? So now, so what is the common column in two table? That is common column here, we say it as giant column, right? So giant column is prod id, which we have in the two tables, right? So that is in the prod info, we have a prod id, and in user info we have user id. So these are the two common columns in both the tables, right? Now you can write, select. So what is that? We have prod info dot start, comma, user info dot start from the table name prod info, right? So what is the giant column we have, right? Now giant user info, right? First one, select all the fields from the first table, comma, all the fields from the second table. Now, so I wrote prod info giant user info, and what is the condition here, right? So we have a prod info dot prod id equal to user info dot user id, right? So this is a inner join. So you can write like this, right? Select prod info dot star, comma, user info dot star from the prod info join user info, and the condition join condition is there should be same prod info dot prod id equal to user info dot user id, right? Invalid column reference user id. TAC user info. Right, we have prod ID is there. Right, so it will take the common value and it will display the common columns in the both the tables, right, where the condition is to be matched, right. The product ID in the username info must be equal to the product ID in the product info. Only those records are going to be listed here. Okay, so this is kind of inner join in Hive, right, where we are going to join the two tables. Right, suppose if you want to see how this is going to be executed, you can write explain. Suppose if you want to write the outer joins, you can write the same thing. Right, from prod info. Now here instead of the join, then write left outer join. Right, like this you have to write. Right, if you want to see how this query is parsed by the Hive, then write. So I have wrote explain. So then it will show you the how this query is parsed by the Hive compiler. You can see this. Right. Right, this is stage one. So it's a map reduce phase. Right, prod info. Right, so we have created alias the prod info. Right, so it took prod ID is an integer. So there is no partition columns, and on the table user info, prod ID is an integer. Right, so there is no partition columns here. Then it performed the join operation. So when it is performing the join, so it took inner join. Right, so it's evaluated the query like this. Then it will output the columns. These columns are outputted. Right, so they type. Right, so I have no compression. I'm not created a sequential format, so compressed is false. Right, so this is the input format and this is the output format. Right, so this is how this query is passed by the Hive. Right, so you can write any query and just add the prefix explain, then it Hive will show you how that query is parsed by the Hive compiler. Okay, now if you want to write the left outer join, so what is the left outer join? Now it will take the left table is going to match with the right table. So whatever the match found, the values in the left table is going to compare with the right table. If it find the match, it will display. If it won't find the match, it will display as null values. Okay, so just write select, right, fraud info dot star comma user info dot star. Right, from the left table here is a prod info, so I'm writing left outer join, the right table is user info, right, and the join column is prod info dot prod id is user info dot user id. Right, the same thing, if you want to write it's a left outer join, right, if you want to write the right outer join, it is same, right, so you have to change instead of the left here, right, right outer join, so you can write the full outer join from prod info instead of the left, right, now here write full outer join, so it will take all the left table columns matching with the right table, so if it find the value it will be listed, if it won't find the value it will be taken as null. Right, so left table, suppose if you take the right join, so instead of the left, right outer join, we'll see in the right table we have the 7 records, but in the left table we have only 4 records. See, right table we have 7, in the left we have only 5. Okay, so now the left table 2 columns are taken as null, right, so this is right outer join, and if you want to write the full outer join, right, so all possible columns with the left table and all possible with the right table are going to be displayed in a full outer join, right, so these are the giants in Hive. So apart from these giants, we have extra, the map reduce giants are available, right, so we call it as map giants, right, so what we'll do is when we are writing the map giants, we'll take the small table, right, in as left table, right, and that is will take the small table into the memory and then performs giants at map face, right? So the advantage with the map giants is, so whatever the small table you're having, that small table will be taken into the memory, right? And then it will compare with the values in the right table, that's a large table, right? So now here this joining phase done at the map phase, right? Generally we'll avoid the reducers in the map giants, and so it won't work with this map giants, won't work with the right outer giant, and we won't work with the full outer giants, right? That's, we cannot do like this. How whatever you're doing with right outer and full outer, we won't do that kind of giants in the map giants, right? So only the simple concept is map giants are, it will load the small table into the memory, right? It will take whatever the small table, right, which will have the less number of records, that will be loaded into the memory, and it is going to match with all the columns in the right table, right? So the advantage with the map giants is like the fast processing of the query can be done with the map giants, and here we want to use the reducers, so the complete mapping is done in the map phase, right? To write this,
Uh,
just look in Shiva, just write select, right? So what is the prod info dot start comma user info dot star, okay? So we have the two tables from, right? So right, so how much time it took? 30.809 seconds, right? Now the query which I wrote is similar and same as inner chain, right? Now what I'll do, I'll write set hive dot optimize dot bucket map chain equal to true. I'm writing set hive dot, right, optimize dot bucket map chain equal to true, right? Now run this query, right? It took 30.787 seconds. It took 30.809 seconds. Right, let's just, I'll write select slash star yes, And I let map join of prod id as a comment line. Right, now I have achieved this in 28.99 seconds. Right, so in the previous execution I took 30 point something 787, and before that one it took 30.809 seconds, right? So with now I did that in 28.997 seconds, right? I wrote this query as a map join. Okay, so I wrote I have specified as a comment line, so start map join and take the product id as a join column, right? So this way we have to write the map side joins.
Is that a comment or query itself, Ajay?
Actually it's a comment line, but it's, see this is a Java comment line, not Hive comment line.
Yeah, but still the execution is in the
Yeah,
map join, right? Just
right.
because we said
Right.
map join,
Yeah, when,
map join.
right, because when it is passed by the map reduce, then it will consider the statement.
Okay.
If you do, if you want
And
to
for
check,
this, before that, we have to set the bucket map join as true, right?
yes, you have to say that. If you want to check all the properties which are specified, see, actually there is a hierarchy. First thing is, whenever the configurations, first it will check the configuration specified with set. Suppose when you're running a query in Hive, so whatever the properties, configurations you have specified, number of mappers, number of reducers, so where the name node is data is available, where the data nodes data is available, right? Everything, the configurations it required to before the process, because the prod info is available in the SDFS, right? User Hive warehouse SDFS means that is available in SDFS. When you're writing the data into the SDFS, that will be stored somewhere into the data node, right? Now, so this all the data is available in a data nodes, right? Where in data node it is creating the data, we don't know anything, right? So then what it will do first, it will use, if you specified any configuration with the set, it will check that, then it goes to the Hive configuration file to check the configurations, that is hive-site.xml, right? Suppose if you're not specified, then it goes to the configuration files. If it won't find it here, then it goes to hadoop-site.xml. If it won't find it, then throw the error, right? To check the configurations, first it will specify the it will check in the user specified configurations, then it checks into the Hive configuration file, then it checks the SDFS configuration file, SDFS map reduce core site.xml. If it won't find, then it checks in the hadoop site.xml. It won't find the configuration anywhere in the system, then it will throw the error. So this is the hierarchy, right? Every property you have to specify like this. If you run set -v, right? So now these are all the properties enabled for this Hive client, right? So this is Java home, this is a temporary directory, right? We can see all the properties here, right? So this is the location where user directory is.
Ajay, for the
Yes,
mapped joins, you said like the smaller table will be stored in the memory, right?
yes.
So what do you mean by that? Like if you
It's
perform the
simple.
joins, like
It's a simple concept, Shiva. Suppose, see,
you mean okay?
let me tell you, it's a suppose we have the two tables, table A, table B. Table A is small enough where we have 10 records, and another table we have it's 1000 records. Now you want to perform the
Yeah,
join. So what is the best thing here? If you take the right table in the join, you will have many number of mappers where you have to join with a small less number of reducers, right? So
yes,
comparing
yeah.
it takes this one, right? Like one to it's like many to one. So what we'll do, if I take the small data into the left table and going to match with right, then it will take number of findings will be less. Correct. Number of mappings will be less. Right. It goes like
Yeah, yeah.
one to many, not many to one. It goes like one to many. That is the
Yeah,
advantage.
you need to compare only 10. You need to
Right.
compare only 10 records, but
Yes.
that is fine. But I mean, even for the joins, like will if even the joins when we perform the joins, even the tables get stored in the memory, right?
Everything
Doesn't it store
everything
in the
will be
memory?
it will take both the tables. Then it will perform the
Oh,
compare. It will take the both the tables and it will take compare. Now here in the map side, it determines which table is the small one that will be taken into the memory, because we don't know, right? We know that only two tables are there. So which is the small table? How you identify, Shiva? How we knows that there are the bulk data is there? So we don't know which is the small table and which is the large table. Correct.
yeah.
If I know that, I can take the table as a left one, but I don't know which table is the small one, which table is the large one. So then what I'll do, I'll write a map chain. So by default, so it will take the left small table as a into the memory, and it will perform the mapping. So this advantage,
Oh, okay.
right? Okay. Any questions here? Lekesh, Vinay,
No, I'm good again.
right? See, I'll take one example here. Right. So I have data like this, right? So you take same the retail client, right? You take Flipkart. So these are the users who, sorry, first we'll see who visited the product. See, now how you identify, suppose there are some users who visited the product, right? So they are will be written into the table who visited the product, but they have not purchased, right? So they have added the product into the cart, or they have selected, they have searched, they have browsed the products, but they have not completed the purchasing. And we have another table that is a purchased, so where users purchased some products, right? So these are the visitors who visited the products, right? So I have the two table, I am going to create the two tables. One table will have visitors, and other table will have the users who purchase the product. Now remember, so you will find the information from the table visitors, because you have purchased the product means before that you have to visit the product, right? So nobody can buy without visiting the product. Correct. So now, so that the information which exists in the purchased must be exist in the visitor table, but the data which exists in the visitor table may not be exist in the purchase table, because all the visitors cannot purchase, but all the users who purchased must be visitors. Correct. So now I have the two tables like this. So here, this is the user id and the product id which they have visited, right? So it's some product price, right, from India. So they have liked it, some any description they wrote, it will be something, the comment, the product, their reviews, some information, right? It's a mapped column. See this, right? So I have a table like this. The table name is prod underscore visit, where I took user id is a string, the product is a string, the view time, right, when they have visited the product is a string, and the country and the price of the product double, right? So any other parameters other than the user id, product id, view time, country, price, whatever you have in the data will be taken as a mapping, right? Both a key is a string and value is a string, right? So I wrote like this drop table, right? If it already exists, create a table. So we have one field, user id is a string, product is an integer, view time, right? So that is a view time, right? So this is the time when they have visited the product, and this is the country from which they have, from where they have visited the product, right? Now, so other parameters, any parameters other than this will be taken as a map, right? Suppose here the product which they have visited, some comments they have liked it, so they wrote some description. So anything other than the regular parameters will be taken as other parameters, right? So I have defined this other parameters as a collection, which is mapping, right? So and I have a partition column based, the partition column is date, right? So row format delimited, each field is separated by the delimiter slash t. So each array or structure is separated by the exclamation symbol. If you have any mapping keys, key comma value, they are separated by the delimiter comma, right? Each line is separated by the new line character, right? So this is a table prod underscore visit. So just create this table, right? So we have created a table, the table name is prod underscore visit, correct? So you can see now DSA prod underscore visit, right? So we have user id, product id, the time and the country. So price is double, and any other parameters, and means other than this, if you have any data in the table, in the input data will be taken as other parameters, will be considered as a mapping, right? Date is a string, right? Now I have the data is available, the data is visitors, right? So I'm writing documents load this data, right? Now let's select star from prod underscore visit, right? Some data I'm having. Now I'll create other table,